Oh, hey there. Welcome to Pepperwood. Welcome to our oldest, longest running weather station. I'm going to tell you a little bit about what we're measuring here. We're measuring precipitation by 3 different methods, wind speed and direction in a couple different ways, solar radiation, temperature, relative humidity, and barometric pressure. But there's more. Like a tree with its roots underground, we're also measuring a suite of parameters below our feet in the soil. Below us here, we've got 4 stacked soil moisture sensors that also tell us soil temperature. And furthermore, we have, they're called heat dissipation probes, but they tell us how tightly the soil is holding on to the water. So you can sort of imagine a competition between the soil and the plants, and it'll tell us something about, when our grass is going to senesce and die for the season. So we measure the rain. Now what? How do we get from up here where it rains to modeling, forecasting flooding way downstream? With partners like Sonoma Water here in Sonoma County, we have a certain series of rain gauges. This brown one behind me is part of Sonoma County's OneRain system, where we monitor rainfall up here in the headwaters where a lot of that rainfall occurs. And then as you move downstream into the feeder creeks, they measure stage and stream flow, and they tie all those measurements together, and they're able to forecast not only how big of a flood, but also narrow down the time it's going to occur, so they can let folks in Guerneville and Montreal lower in the Russian River know, hey, it's time to get out, and in essence, saving lives and property that way. And one more thing about the flooding. If we have the rainfall here and we have the water flowing into the creeks there, where does it go in between? What's the pathway to get there? Our soil moisture sensors tell us how that rainfall is making it into those creeks and ultimately adding to that flood. If we can look at our values of soil moisture and we know that those soils are saturated, meaning they can't hold any more water, and they're only going to let new rainfall enter as fast as they drain, which can be pretty slow. So if we know our soils are saturated and they only move a ½ inch of water an hour, something like that, and we know we're getting more than ½ inch an hour of rainfall, we're going to generate overland flow and runoff, and that water is not going to enter the soil and slow down. So you're going to have rapid delivery of that precipitation into the creeks, and you're going to have much more dramatic and faster response times for flooding. Another reason to care in our second natural disaster, fires. Here at Pepperwood, we have been the overlap of both the Tubbs fire in 2017 that came through this way and the Kincaid fire in 2019 that came the other way, and both those fires overlapped right here at Pepperwood. So having measurements that let us understand fire weather and fire behavior at this location is really critical. So behind us, I mentioned earlier, we have wind speed and direction, and wind, both the speed and direction are really the drivers of where's that fire going. We also have temperature and relative humidity. And when you set the stage, let's say it's late summer, early fall, and you have low relative humidities, meaning it's really dry outside, and you start to pick up wind speeds, all it takes is a spark. And unfortunately, the sparks are people a lot of times, whether it's mowing the lawn or some sort of accident or a power company and poles coming down. If you put a spark on material in those conditions, you're going to have a fire. And so if we can understand those conditions in real time, like with weather stations like this, we can try to get ahead of it, and emergency response can stage appropriately, and so we can start to nip some of those disasters in the bud and get ahead of them before they become a bigger thing.